Hi, this is Martin from IFAC. In this video, I will present to you our results from the collaboration with Parasoft on the topic of using MQTT-based test adapters and model-based testing to enable testing for various industrial protocols. Let's talk a bit about the problem that we try to tackle in the collaboration with Parasoft. Imagine a simple example. You are on one of your travels and you have to recharge your phone. However, the existing wall outlets are not compatible to the type of cable that you have with you, so there's no existing port where you can actually plug in your cable. In this case, you usually have some kind of adapter, which you can use to charge your phone on one of the existing wall outlets. But to stretch this problem a bit, imagine there's also an existing storage device, which actually includes the instructions on how to charge your phone. In this case, to map this example on the actual use case that we tried to tackle, the phone is in this case a test tool, in this case SOA-Test by Parasoft. The wall outlets are simply industrial protocols that we need to support to actually test for different SUTs. The adapter in this case is a simple test adapter, and the USB stick that you see here are the generated test cases provided by our IFAC MBT tools. As you can probably already see here, there are two kinds of distinctive problems that we try to solve in our collaboration with Parasoft. On one hand, we try to enable SOA-Test, the tool by Parasoft, to execute our generated test cases, which are provided by our model-based testing toolchain. On the other hand, while SOA-Test supports a wide array of different interfaces and protocols, it is currently not able to communicate via some industrial protocols that Parasoft is currently interested in. So, for this case, we are also using our IFAC test adapter to enable SOA-Test to communicate via these industrial protocols and therefore test different industrial test targets using these special protocols. Next, I would like to shortly present the concept that we have developed for integrating our model-based testing toolchain and the IFAC test adapter with SOA-Test. In the beginning, we are importing requirement documents into our IFAC MBT web. There we are turning them into requirement models, which are then used for model-based test generation. So, the output of our tool is an abstract test suite, which actually does not yet contain any protocol-specific information. Each test case is very generic and very abstract. To actually import these abstract test steps or test cases into SOA-Test, they first have to be converted into a format which can be understood by SOA-Test. In this case, we have written a program to convert them into a CSV file, which can then be imported by SOA-Test. To run the individual test cases, SOA-Test actually sends each individual test steps to an IFAC test adapter. These test steps, which are still very generic, are then interpreted by the test adapter and turned into actual messages, commands, or the requirement communication form required and necessary for the target SUT. The SUT usually also answers in some form, and this answer is then interpreted by the IFAC test adapter, and the answer also sent back via MQTT to SOA-Test. Using this concept, we are able to use model-based testing in combination with SOA-Test and also extend SOA-Test testing capabilities for industrial protocols it did previously not support. The test case import can be summarized quickly. As I already said, the test generation outputs an abstract test suite. This abstract test suite includes a test logic, basically consisting of several test steps, which are converted in a first step. For the conversion of this first step, we are using generic test steps understood by SOA-Test. Basically, in this case, an MQTT read command, an MQTT write command, or in MQTT world, basically a subscriber or a publisher, and also additional elements like timers. Also from the abstract test suite, we are importing test data and adding them to the existing test steps. The converted test data and the test logic are outputted as a CSV file, which is then again imported by SOA-Test, where it can actually run the predefined test steps. Basically, that's already the import. Let's have a look at a small example of how such an abstract test case might actually look like. In this case, we are sending a message to the IFAC test adapter. The message has a certain name, go-to position, and a numeric value. The IFAC test adapter receives this message and translates it into the target protocol either as a message or a command, which can be understood by the SUT. As the next test step, we expect an answer back from the SUT. So we are again defining a message name that we expect and a certain value, which will be checked by SOA test. The IFAC test adapter translates all messages it receives by the IFAC by the SUT and transforms them into MQTT messages and sends them back to SOA test. We can repeat this for different kinds of types for values, like in this case a boolean. Also, as you can see, we support either polling of values or directly reading them. The IFAC test adapter supports a number of protocols. One of them is OPC UA, ModBus, and UDP. The IFAC test adapter was designed and developed with extensibility in mind, so it's modular and easily extendable for further industrial protocols. Next, we are switching over to the IFAC MBT tool. Here we are accessing the generated test cases that we have prepared for this video. In this view, all generated test cases are listed, and we have 241 test cases overall. Each individual test case can also be visualized if necessary. Next, we are exporting our model-based tests via our export feature. Here we are seeing the CSV file as exported by our model-based test tool. Each line in this CSV file basically stands for one test step of all test cases. For each test step, we define a command and test data as a number of parameters. Additionally, we have some additional information like a timeout, a polling rate, and the accuracy. Next, we are switching over to SOA test by Parasoft. Here, we are now importing the CSV file that we have just created. For that, we can create a data source, and inside the data source, the path to the CSV file, and some additional information how it has to be passed. SOA test actually runs each line of the CSV file as one separate test case. For that, we have together with Parasoft created a state machine-based approach in which each test step is implemented separately by one element in the SOA test. We have defined the test flow logic where each of the lines in the CSV file and especially the command of each line is checked and the associated test step in SOA test is executed. Here we see an example for sending for a write message element. We define the actual request as a JSON and define some additional information like the MQTT server URL and a topic. Each of the parameters of the JSON is parameterized and taken directly from the CSV file. Similar, it looks for reading messages. Here we are also defining, or in this case we are defining an MQTT subscriber element, and we are defining a read message element which actually triggers the test adapter to check for incoming messages which are asserted and checked inside SOA test. Now, basically after importing the CSV file, we can already start the test run and have currently all tests running. We have evaluated this approach for different industrial protocols. On one hand, we have evaluated it for ModBus, as you can see in the following example. Additionally, we have also evaluated it in context of the Akka use case, which is actually using UDP to communicate, as you can see in the following example. At last, we have also evaluated it for OPC UA, although in this case we are running tests directly against an OPC UA server, so not that much can be seen in this example. There are a number of interesting results from the collaboration from which both companies will profit. On one hand, we have proven that running model-based tests in SOA test is feasible not only in theory, but also in practice. Also, from a point of view of Parasoft, we have now extended testing capabilities of SOA test for various industrial protocols in which they are currently interested in. From our point of view, IFAC MBT now supports SOA test for test execution and also supports a new export format for our model-based tests. This is the result video from the collaboration between Parasoft and IFAC. Thank you for watching this video. Goodbye.